Hey there, and welcome to today's Explainer. I'm going to be acting as your personal career advisor today to map out what is honestly an incredibly bright future in green technology. If you're an incoming engineering student right now, and you're trying to figure out which branch offers the absolute best return on your educational investment, you are in the exact right place. We are going to explore a very specific, highly specialized degree, the B.Tech in Chemical and Electrochemical Engineering.
So let's kick things off by asking a pretty massive question. Are you ready to be the specialized solution to the world's most critical bottleneck? Right now, we're right in the middle of this gigantic global transition away from fossil fuels. And honestly, the world is desperately searching for engineers who actually know how to build the clean energy devices of tomorrow.
Here is our blueprint for your success today. We'll quickly run through your green energy mission, the hybrid advantage of this degree, your academic roadmap, real-world apps and internships, global careers, and finally, some strategies for getting top grades.
Let's start with Section 1, your green energy mission, driving the clean transition.
Just take a look at these global demand drivers. We're talking net zero carbon targets, massive EV expansion, decarbonizing heavy industries. What's absolutely fascinating here is how this entire clean energy landscape fundamentally relies on molecular-level charge transfer physics. Think about it. High power density batteries for cars, green hydrogen electrolyzers, these aren't just software issues. They are complex electrochemical problems. The world needs people who deeply understand electrolytes and membranes, because when you advance one of these areas, you literally accelerate them all.
Moving right along to Section 2, the Engineering Hybrid Advantage, a strategic academic choice.
Okay, so what exactly is this hybrid advantage? Well, let's break it down. Traditional chemical engineering is mostly about fluids and scaling up huge processes. Think petrochemicals and Navier-Stokes equations. Material science? That focuses heavily on solids and crystals, like aerospace alloys. But electrochemical engineering? This is where it gets cool. You get to master the multi-phase interfaces where those solids, liquids, and gases actually meet. Instead of just dealing with bulk fluids or bulk metals, you're using models like Butler-Volmer to control active devices like batteries and fuel cells. It gives you a dual focus that makes you virtually irreplaceable.
To really ground this blueprint, we're looking at the flagship framework from Anna University and the incredible CSIR-CECRI National Laboratory. Established way back in 1948, this is a sprawling 300-acre premier lab, actually the largest electrochemical laboratory in the Asia-Pacific region. You'd be studying in an intensely immersive, AICTE-approved research environment, getting your hands on world-class facilities right from the start.
All right, Section 3, your academic roadmap, looking at your year-by-year progression. So how does this actually unfold for an incoming student? It's a beautifully systematic buildup. In Year 2, you're laying down the foundation: thermodynamics, fluid operations, core calculations. By Year 3, you dive into the really specialized stuff like electrochemics and reactor design. Then in Year 4, you apply the whole shebang to advanced energy systems and your big capstone project. In just a few short years, you go from learning the math to actually designing the clean energy systems of the future.
Now, I want you to pay close attention here, because these core program outcomes aren't just academic fluff. Applying math, designing energy-efficient processes, using modern simulation tools, these are the exact professional skills hiring managers are begging for right now. You're not just studying to pass a test. You're molding yourself into an adaptable, safety-conscious innovator who actually promotes sustainability.
Which brings us perfectly to Section 4, real-world apps and internships, bridging theory to practice.
This is my favorite part, because it's where theory gets real. You are going to take a classroom concept like electrocatalysis and translate it directly into designing hydrogen fuel cells. When you study mass transfer, you're literally learning how to make an electric vehicle battery charge faster without it catching fire. And microdisc voltammetry? That's the exact science powering the blood glucose sensors used by millions of people in healthcare every single day.
On top of all that, you're going to become super proficient with advanced simulation tools like COMSOL multiphysics. Long before a physical battery is ever built on an assembly line, you'll be simulating the Nernst-Planck transport equations digitally. You'll model current distribution and optimize thermal management for massive electrolyzers, which, by the way, saves companies millions of dollars in R&D.
But hey, you can't learn it all sitting behind a computer screen. That's why there's a mandatory 8-semester industry project or internship. Seriously, never underestimate this.
Getting out there onto the industrial shop floor or into a corporate clean room provides the exact hands-on experience and networking that lands those top-tier job offers before you even walk across the graduation stage.
Let's talk about the payoff in Section 5, Global Careers and Salaries, your lucrative reward.
100%. Yep, you heard that right. Because you have this highly specialized dual skill set, mastering both traditional process scaling and advanced electrochemistry, this program frequently sees near 100% campus placement records. You just do not see that kind of demand in broader, more generalized engineering degrees.
And just look at the heavy hitters recruiting here. You've got automotive and tech giants like Tesla, Lockheed Martin, Hyundai, and TVS Motors. You've got battery leaders like Exide and prestigious government research organizations like ISRO and DRDO. Whether your dream is to build space-grade fuel cells or next-gen consumer EVs, the doors are absolutely wide open for you globally.
And the financial return? It completely matches that massive demand. The overseas opportunities are vast. If you look at average salaries for related top-tier roles, like bioprocess engineering in the United States, they can reach well over $114,000. The potential here is just tremendous.
Finally, let's wrap up with Section 6, Strategies for Top Grades, Mastering the Material.
Listen, as your career advisor, I've got to be real with you. This degree is rigorous. It integrates multivariable math, physics, and chemistry. Mindless rote memorization will fail you entirely. You need a three-stage approach. First, build your foundation by cross-referencing multiple sources. Second, apply it through active problem-solving. No plug-and-chug math allowed. You have to justify your steps. And third, optimize by tackling those really complex multiphysics transport problems.
I also love this advice from past successful students about the Feynman method. It is the ultimate engineering study hack. Basically, if you can't explain a complex physical concept to a classmate in simple language, you just don't understand it deeply enough yet. Try teaching the material out loud to your study group. It's the fastest way to spot your blind spots.
So let's pull all of this together. By bridging the gap between massive process scale-up and tiny interfacial electron kinetics, your future skills literally make you irreplaceable. You're stepping into a career path that doesn't just promise great financial security, but gives you the actual tools to build the zero-emission infrastructure of tomorrow.
I'll leave you with this final thought. While everyone else is just talking about climate change, are you ready to step into the lab, master the science, and actually engineer the solution? The sustainable future is waiting for you. Thanks so much for joining me on this explainer, and I really hope this blueprint helps you kickstart an absolutely incredible career.